This is the story of spaceflight for today and beyond. It is the story of dreams come true.
Flying untethered in space is probably one of the premier experiences of this half of the century.
And nightmares realized.
Challenger, go and throttle up.
America's space program will never be the same again.
It is a story of startling possibilities.
They are going to put up this space laser. That's going to be the world's biggest flashlight militarily, but is going to shock this country in a way that it hasn't been shocked since Sputnik.
What are the plans of the superpowers? Who else is joining the race for space? And how long will it be before we begin the journey to the stars? The territory ahead, next on Spaceflight. The countdown has commenced.
Okay, I got it in there now.
April 1972. On the next to last lunar mission, Apollo 16 astronauts John Young and Charlie Duke unfurled the American flag in the moon's vacuum.
Come on out here and give me a salute. Big Navy salute.
As the ambitious Apollo program draws to a close, a new direction is announced for America's space effort.
This looks like a good time for some good news here. The House passed a space budget yesterday, 277 to 60, which includes a vote for the shuttle.
Wonderful. Wonderful. Tony, again, I'll say it with that salute. I'm proud to be an American. I'll tell you, what a program, and what a place, and what an experience. Yeah, and I'll say it too. So my country needs that shuttle mighty bad. You'll see.
After Apollo, 6 years would pass before another American astronaut would again return to space. In those 6 years, manned space belonged to the Soviet Union. Though less spectacular than America's moon landings, the ongoing Soviet program has produced invaluable experiences in living and working in space. Today, Soviet cosmonauts have nearly tripled the amount of time America's astronauts have spent in orbit. Soviet space observer James Oberg.
The last several years have been a remarkable level of maturity, boldness, and even ingenuity shown in their manned operations in orbit with the Salyut 7 space station, which was launched about 1982. What we've seen the Russians do with their months and months and months in space, and then now, in fact, man years of spaceflight, is not just clock time, but accumulate confidence. On the Salyut 7, there were breakdowns, as there are on any kind of spacecraft, but the Soviets, uncharacteristically for them, didn't just cancel missions or launch new vehicles, but they undertook some very bold repair missions. Those are the kinds of things that we used to think were American specialties. But we've found that with operational experience on orbit, Soviet cosmonauts and their engineers and planners on the ground are capable of very fine flying, very sophisticated operations in space, and I'm sure it's going to continue.
The Salyut was the Soviet Union's second generation of space stations. What made them different was the addition of a second docking port. Crews dock on one end of the station while mission supplies, food, fuel, and other materials are automatically ferried into space aboard an unmanned spacecraft called Progress. This engineering achievement has allowed the Soviet Union an almost continuous presence in space. Raoul Segdeev, director of the Soviet Space Research Institute.
Manned versus unmanned mode of space activity is a very delicate problem, and to find a balance is a very delicate issue. But if you would send Progress in unmanned mode, you could deliver several tons of equipment on board. If you would send a crew, then you will have only very small place for additional equipment. So, arguing in this way, we decided that the proper balance would be to have both types of approaches.
The Soviets' only serious setback in recent years occurred in September of 1983. During the final seconds of countdown, the rocket supposed to launch the Soyuz crew into orbit caught fire and exploded. The crew ejected and survived, though no report has been made public of the extent of their injuries. Marcia Smith.
If you step back from the programs and look at them historically rather than in today's setting, I think that you would notice that there seems to be a race, as the race between the tortoise and the hare. The United States tends to do things in fits and starts. We had Mercury and Gemini and Apollo, and then we stopped flying people for 6 years, and then we came on board with a shuttle. The Soviet Union has relied on older technology, but they do get things done eventually. And so with their long-term commitment to space, they've been able to have this logical progression of space programs, and they may be viewed as the tortoise because it takes them so long to do things, but you know what happened in the race between the tortoise and the hare.
After Apollo, America's space agency, NASA, turned its attention to building the world's first reusable spacecraft. Original plans called for a shuttle to be composed of 2 separate manned vehicles. The first would be a huge but reusable rocket plane to boost the shuttle into orbit. The manned rocket launcher would then return to the launch site. Budget constraints altered this plan, and a compromise was made. The manned rocket launcher was dropped. Instead, 2 reusable rocket boosters and a large throwaway external fuel tank were designed. Chief NASA Administrator James Fletcher.
We did make a major compromise in not going for a fully reusable transportation system. It was a partially reusable transportation system. That was a compromise between what we thought we could do in a given period of time and the amount of money that was available and a lot of other things, presidential requirements.
By the time the shuttle is rolled out for its first powered flight, it is 2 years late and $1 billion over budget. Developing reusable rocket engines had proven an awesome engineering assignment. Receiving the most public attention, the shuttle's heat shield tiles. The 30,000 individually cut pieces of tile were designed to protect the shuttle from the intense heat of re-entry, but the tiles refused to stay on, even in atmospheric tests. Former director of the Johnson Space Center, Christopher Kraft.
There were many people that thought the space shuttle would burn up, a lot of smart people that thought the space shuttle would burn up during re-entry, that we were doing things wrong, that the tiles would not stay on the machine, that they would not survive the re-entry, that there'd be vibrations and forces on the tiles that would rip them off, that the stability and control of the machine was poor, and that the computer systems and the automatic control systems that work through the computer would be insufficient to properly control the machine during entry. All kinds of doubts in people's mind that during launch it would come unglued.
April 12, 1981. Countdown for the maiden voyage of America's first space shuttle, Columbia. On board are astronauts John Young and Robert Crippen.
Physically, riding the shuttle is a real thrill. I don't think I know of any other kind of a vehicle that could give you that kind of a ride. It starts about 6 seconds prior to the actual liftoff when we ignite the main engines. And the vehicle begins to shake, and there's a loud sound of the engines themselves. And then we light the solid rocket motors, which each put out 2.5 million pounds of thrust. And unlike some of our previous expendable boosters that lifted off kind of nice and slow, when those solids light, you're up and going, and there's no doubt in your mind that you're headed someplace.
Roger, roll.
Yeah, everything looks nominal there, man. What a view, what a view.
Glad you're enjoying it.
Daniel, that was one fantastic ride.
Well, wish we could have been along.
Yeah, I highly recommend it.
Successful in reaching orbit, Crippen and Young inspect their craft. One view from the cargo bay confirms one of NASA's greatest fears. All or part of 16 heat tiles are missing.
We do have a few tiles missing off of both of them.
Roger, Crip, we can see that good.
The mission commander, John Young.
Of course, when we flew the first mission, we'd participated in many hundreds of engineering meetings where people had told us that when we returned, we would have statistically, now mind you, statistically, we'd have lost some tiles off the bottom of the vehicle.
Some engineers speculated prior to the flight that even one missing tile could cause a zipper effect, leaving the shuttle perilously vulnerable to the scorching temperatures of re-entry. There is only one way to find the answer as Crippen and Young begin the fiery descent back through the Earth's atmosphere.
Speed 271 knots. So it says it couldn't be any better.
On glide slope. Approaching center line. Looking great. 30, 20, 10, 5, 4, 3, 2, 1, touchdown.
It's a very complex process to put on 30,000 tiles on a vehicle. Very labor intensive, and you can hardly believe the variety of people that worked on that vehicle. It takes about that much paper to put on one single tile, and they did it just right.
NASA has staked its future on the shuttle. It hoped that this reusable glider would make access to space routine and relatively inexpensive. Like a freight company, NASA would pay its own way by lifting commercial satellites into space. America's first woman in space, Sally Ride.
The satellite deployments that we had on STS-7, my first flight, went very smoothly. From the moment that we powered up the satellites and started the deployment process to the time that the satellites made it to geosynchronous orbit, there were virtually no problems.
Beautiful.
In 1983, 2 shuttle-launched satellites went astray due to booster failures.
The problems that they saw on those satellites had nothing to do with the space shuttle. Unfortunately, the shuttle goes to a low Earth orbit. It doesn't make it up to geosynchronous orbit, so we can't just take a satellite that's designed for geosynchronous orbit and leave it there. We've got to have some additional booster on the satellite to get it from the low Earth orbit to the geosynchronous orbit. And it's those boosters that we've had a little bit of problem with.
But having lost satellites, NASA has also rescued them. In April of 1984, the crew of the Challenger makes a house call in space. For the first time, they are to retrieve, repair, and return to orbit a damaged satellite, the Solar Max. Looking like a scene out of science fiction, astronaut George Nelson flies out into space and attempts to attach himself to the satellite.
Flying untethered in space is probably one of the premier experiences of this half of the century, I think. We figured we'd rendezvous with the satellite, and then the satellite was tumbling, so somehow we had to stop the satellite so we could grab it. And we had planned to do that with the maneuvering unit. Of course, that didn't work.
You're going to have to hold on to it with both hands, I imagine.
The locking pin on Nelson's docking device fails to capture the satellite, and it begins a slow tumble out of control.
I don't know if I'm going to have enough gas to do that. Oh, what you got left? What you got left?
Low on fuel, Nelson abandons the rescue and returns to the shuttle.
Okay, come on back in, thanks.
After the first day, when the docking attempt failed, then the satellite was left in worse shape than we'd found it. It was actually tumbling kind of randomly end over end. And people on the ground performed really a minor miracle to stabilize the satellite. I mean, they stopped it with about 15 minutes of life left on the batteries in it, and they were lucky enough when they stopped it that it was pointing at the sun so that its batteries could be recharged.
Challenger Houston standing by through Yargety.
Okay, we've got it, and we're in the process of putting it together.
Outstanding.
The crew of the Challenger uses the shuttle's manipulator arm to capture the satellite. For almost a full working day, astronauts perform the first repair of a satellite. This impressive achievement was surpassed in November of 1984 with the rescue of 2 satellites lost to wild orbits a year earlier. The 2 errant satellites are hauled, literally by hand, into the shuttle's cargo bay. Although the satellites are virtually weightless, they are dangerous objects to handle as they are full of highly toxic fuel.
Okay, I got my little grubby hands on it. Now you just kind of let me take it where I want it, okay? Yeah.
Secured in the cargo bay, they are returned to Earth for repair and resale, a major demonstration of the shuttle's ability to work in space. By 1985, there seemed little the shuttle could not do.
The experiments are working out very well.
we're very pleased with the results we're seeing. And
So commonplace were the flights that U.S. congressmen could be found riding aboard, justified as part of their congressional oversight responsibilities. President Reagan announced that the first civilian to go into space would be a teacher.
I've made 9 wonderful friends over the last 2 weeks. And when that shuttle goes, they might be one body. But there's going to be 10 souls that I'm taking with me. Thank you.
That's great.
For the public, the flights of the space shuttle had become routine events. But for NASA, the pressures of meeting ever more ambitious schedules were causing enormous strains on people and machines. Lawrence Malloy.
So there were some 800 items on the space shuttle vehicle which did not have redundancy. Those were classified then as criticality 1, meaning that the failure of any one of those systems, a single failure, would be catastrophic.
One critical problem, unknown even to the astronauts, concerned the 2 solid rocket boosters. New York Times science journalist John Noble Wilford.
You have these 2 booster rockets, one on either side of the fuel tank, that provide the primary thrust for the shuttle during the first 2 minutes of ascent. And these are solid fuel rockets, and they come in segments. The segments are stacked, and at the attach joints, you have a ring made of synthetic rubber that seals those joints. And what you have, of course, there are a lot of dynamic pressures at launching, and the pressure sort of stretches and twists.
Before the shuttle ever flew, test firing showed that the joints of the booster's 4 major sections were opening instead of tightening as designed. This problem was not corrected. It would fall on 2 thin rubber O-rings circling each joint to keep 5,000-degree flames from escaping out of the side of the rocket. As early as the second shuttle flight in November 1981, engineers had found serious scorching of a primary O-ring.
And some of the people from headquarters, after they heard about this, went down to Marshall Spaceflight Center in Huntsville for further meetings to try to find out, well, and I don't know that the full story has been told on why the decisions were made that were made, but in effect, the problem was swept under the rug.
Yes, what happened in January of 1985, we experienced hot gas blow-by, the most severe that we'd ever seen up to that point. And in removing the seals from the joints in June of 1985.
One man trying to bring attention to the problem was Roger Beaujolais, then a technical troubleshooter for Morton Thiokol, maker of the solid rockets.
Should the occurrence that happened on that second flight ever occur in a field joint, we would stand in jeopardy of losing a flight along with the vehicle and all the pad facilities, because at that time we thought it was an event that would occur right on the pad before it even cleared the tower.
In July 1985, Beaujolais would write this memo warning of a catastrophe of the highest order, loss of human life. Plans began to redesign the faulty joint, but the shuttle continued to fly despite increasing warnings of scorching. January 28, 1986, and the 25th mission of the space shuttle.
Commander Dick Scobie, followed by Mission Specialist Judy Resnick, Ron McNair, and pilot Mike Smith, followed by Krista McAuliffe, teacher in space, Ellison Onizuka, and payload specialist Greg Jarvis. Big smiles today, confidently getting into the van.
It's rather clear to me that the message had gotten through the ranks that the boss, that the administrator, the White House, the Congress expected NASA to be able to live up to what it said it could do, which is launch this thing on schedule and frequently.
The Challenger crew of 7 includes America's first civilian, schoolteacher Krista McAuliffe. McAuliffe's presence brings special interest to a flight already plagued by numerous launch delays.
This was an event. By putting Krista McAuliffe on the flight, it was not just another routine flight. It was a nationwide, indeed an international event with lots of things scheduled to focus on it. And so, sure, there were layer upon layer upon layer of pressures that said, let's go.
But on the eve of the flight, freezing temperatures and high winds had again raised concerns about the solid rockets. Engineers worried that the bitter cold would make the rubber O-rings brittle and incapable of sealing the faulty rocket joints. As the crew boards the Challenger, they are unaware of the debate that has taken place the night before between NASA and Morton Thiokol.
We had heard during the day that the overnight predicted temperature was going to be 18 degrees, so we spent considerable period in meetings with our management, engineering management, to convince them that we ought not to launch in those conditions. I took some photographs that showed the condition of the joint that had leaked in January of 1985, which was the most previous coldest launch up to that time, and it clearly showed in the photographs that the black soot was much, much worse than the soot blow-by that occurred at a room temperature launch, which was an issue of discussion that night. The managers would have no part of that discussion. Actually, I got looks as if to say, don't bother me with the facts. It was subsequent to that the general manager asked the vice president of engineering to take off his engineering hat and put on his management hat. And to that, they took a poll, and all the floor managers voted to launch without any restrictions whatsoever in temperature.
27.
Lawrence Malloy of NASA had argued that the available data had shown no conclusive evidence that the shuttle could not fly. He would accept the contractor's recommendation to launch.
And in driving away from the Cape that night, it was just another late night, going till 11 o'clock, which was not at all unusual in the system. In thinking back, in hindsight, about the whole evolution of this problem, I think that the error was in continuing to accept a design that was not behaving like it was intended to. We didn't do anything to correct that design. We continued to accept the risk and continued to fly. And in April of 1985, when we had complete erosion of a primary O-ring and significant erosion of the secondary O-ring, and had a series of meetings that were every bit as intensive as the one that occurred on January the 27th, and accepted the contractor's recommendation to accept that as an acceptable risk, reviewed that with the total management structure of NASA, and accepted that risk, is where I think the fatal error was made.
OTCPLT, caution warning, memories cleared, no unexpected errors. Copy.
T-minus 30 seconds, and we've had a go for auto sequence start. The SRB hydraulic power units have started.
With schoolteacher Krista McCullough on board, many of the nation's children are watching the event on television. Soon, the exhilaration of the shuttle launch will turn to horror.
T-minus 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1. The 25th Space Shuttle mission, and it has cleared the tower.
Control program. Roger, roll, Challenger.
Good roll program confirmed. Challenger now heading down range. Engines beginning throttling down now.
3 at 65.
65, Fido.
TDL confirms throttles.
Thank you. We'll throttle down to 65% shortly. Engines at 65%. 3 engines running normally. 3 good fuel cells. 3 good APUs. Velocity 2,257 feet per second. Altitude 4.3 nautical miles. Downrange distance 3 nautical miles. Engines throttling up. 3 engines now at 104%.
Challenger, go at throttle up. Challenger, go at throttle up.
One minute, 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles.
Spaceflight GC, we've had negative contact, lost downlink. Okay, all operators, watch your data carefully.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction. We have no downlink.
I had wandered up into the area where we normally watch the launch, and I was walking by that room when a colleague came out of the room and asked me to come in, encouraged me, in fact, to come in and watch the launch, and I decided not to, and finally he convinced me that, oh, come on in and watch the launches. You ought to see it, you know. So I sat down on the floor closest to the screen. While he was sitting in the chair, I was up against his legs. It took off, cleared the launch tower, and he whispered in my ear that we just dodged a bullet. About T plus 60 seconds, he whispered in my ear, and he said, I just completed a prayer to the Lord, thanking him for a successful launch. And 13 seconds later, we saw the horror of destruction in front of our eyes.
After liftoff, we do have a good view from that glass cage of the ascent. And I recall somewhat, just slightly a minute into the launch, seeing some bright objects in the plume. And my initial thought was that we've either lost the main engine or that we've had a burn through of the solid rocket motor nozzle. That was followed very shortly by the explosion. I saw the objects, I saw the expansion of the plume, and then the explosion. And it was absolute shock. There was absolute silence in that room. Nobody spoke. And when they did, it was in whispers.
Flight Fido, go ahead. RSO reports vehicle exploded.
It is believed that the crew members survived the initial explosion.
Copy. Fido, can we get any reports from recovery forces? Stand by.
At least 3 emergency breathing packs were activated. Whether conscious or not, all 7 died some 2.5 minutes later when their capsule compartment hit the Atlantic Ocean, like this shuttle debris, at a speed of over 200 miles an hour. The immediate question following the accident was, how had it happened? A presidential commission was formed to find the answer.
The process as it worked in this case was clearly flawed.
The technical culprits did turn out to be the faulty joint and O-ring seals, but these were symbols of NASA's deeper flaws.
265 feet.
The shuttle's brakes had malfunctioned so many times that the runway at the Florida blastoff site had to be abandoned in favor of the large dry lake at Edwards Air Force Base in California. Stretched too thin, there was a constant shortage of parts. There was also a severe strain on personnel. On the mission previous to the Challenger, the crew of the Columbia avoided disaster by just 31 seconds. Their launch abort occurred because a fatigued console worker had mistakenly drained 18,000 pounds of fuel out of the shuttle's external tank. It now seems clear that NASA's management accepted goals greater than it could achieve.
There's no question that the press was lulled by NASA's successes. That the press did not dig as hard and as deep as it should have into the various issues concerning the space shuttle.
Astronaut George Nelson scheduled to fly aboard the shuttle's first post-accident flight.
Yes, we needed to know that data, and we didn't. And that was made us all a bit angry, I think. And we have been working very hard with the system to try and ensure that that never happens again. That if there is a problem, it will be identified as the problem with the O-rings in the solid rockets was, but that information, after it's identified, is passed along to everyone who needs to know, so the problem can be worked in the proper way. And I'm pretty satisfied right now that the system we have in place will do that.
James Fletcher now has the responsibility of putting back together the pieces of America's shattered space program.
Morale is low. The papers are not treated as well. Some of them made us look like a bunch of idiots, and there were mistakes made, but we're not a bunch of idiots. We're competent people. I don't want to say super people, which we sometimes get credit for. Not now, but we used to. We're just ordinary people trying to do a job, but the only reason we're successful is because we worked together in the past. We have worked together as a team, and each player knew what the other fellow was supposed to do and trusted him, and that team atmosphere is not quite back yet, but is getting there.
Fletcher hopes to have the shuttle program flying again in early 1988, but there are allegations that NASA is charging ahead too quickly. In the rush to fly, is NASA making the same dangerous mistakes?
I think that, in all honesty, unless a total ethical change is made at the upper echelons of both government agencies and contractor agencies, something similar will happen again, because the contract pressure, the schedule pressure, and the cost pressure will drive people right into the same spot. And unfortunately, the astronauts will pay very dearly, the ultimate being their lives.
Whenever you're ready, Bobby. Okay, why don't we all gather over this?
Well, much more than 7 human lives and a very expensive piece of hardware were lost. What was lost was an impression of something that we could be proud of, that the space program was what the United States did well, did right, was a symbol of national accomplishment, national pride. And the accident and then the investigations following the accident have demonstrated a large degree of illusion to that symbol. I think our confidence in the space program, in NASA as an organization to carry it out, in space as an activity to use to identify what's good and positive and right about American society, all of that has been very badly shaken and will take quite some time to restore and reconstitute that sense of pride.
To those they left behind, the mothers, the fathers, the husbands and wives, brothers and sisters, yes, and especially the children. All of America stands beside you in your time of sorrow.
The United States is not the only country with space shuttles. The Soviet Union is reported to be building its own reusable space vehicle.
The Soviet shuttle, according to the U.S. Pentagon, is in development, and in addition to a full-scale shuttle the size of ours, the Soviets are also developing a smaller version called the space plane. The big shuttle, what we call the Soviet shuttle, has not been flight tested to the best of our knowledge. The smaller space plane, there have been 4 flights of this, but the most recent was back in 1984, so we don't know any more about the status of that program.
The U.S. Air Force has on the drawing board its own advanced aerospace plane, a craft capable of carrying a 20,000-pound payload directly into space from a conventional runway. Space, for the modern military strategist, is the new battlefield. The U.S. Defense Department now spends nearly twice as much money on space as NASA, and the distinctions between military and civilian space programs are becoming increasingly blurred. The Air Force has its own version of Cape Canaveral at Vandenberg Air Force Base, California. For years, Vandenberg has been the blast-off site for satellites on expendable boosters. Here, a new shuttle launch facility has been built at a cost of $2.8 billion. But according to one congressional report, the Vandenberg shuttle pad is poorly designed. Exhaust from the shuttle's main engine could fill the pad with hydrogen gas, resulting in a massive detonation during launch. For now, Vandenberg shuttle pad has been placed in mothballs while it is repaired. Still, the announced flight schedule of the shuttle is dominated by a backlog of military payloads. Nearly half of the cargo bays will be filled by Department of Defense needs. The next generation of American spy satellites, codenamed Keyhole 12, is so large it can only be launched in the shuttle's cargo bay. There is wide speculation that this reconnaissance requirement is a major driving force in getting the shuttle flying quickly again. Just how much detail and information can be spotted from space is a secret, but it is known that America's spy satellites possess an extraordinary capability. John Pike of the Federation of American Scientists.
if you were sitting out in the backyard having a picnic, the satellites could certainly count how many people were at the picnic. They could certainly count how many places were set at the table. They could count all the plates, and they could probably tell whether you were having watermelon or cantaloupe for dessert.
The more commanders rely on satellites, the more tempting they become as targets. America realized this and developed the first anti-satellite weapon, or ASAT, in the 1960s. It used a nuclear warhead, which was so effective as to be totally indiscriminate, destroying both enemy and friendly satellites. The Soviets responded by creating their own ASAT. Besides ground-based efforts, the Soviets have developed and tested a killer satellite. When in close range, it explodes like a space-age grenade. The United States is making the next move with a new anti-satellite weapon. The American ASAT is carried aloft by an F-15 fighter. It's about the size of a basic air-to-air rocket, but contains extraordinarily precise heat sensors to track its target. Military thinking is moving far beyond ASATs. The Pentagon and the Soviet Union are looking ahead to bigger systems, systems that can strike at the speed of light, the laser. And the Soviet Union may be leading the way. Clarence Robinson.
We believe that in the physics aspects, the Russians are probably ahead of us. We are perhaps ahead of them in the sensor surveillance capability and the onboard data processing required to track and engage targets. You should, however, realize that that's not limited only to anti-satellite capabilities. Any laser that can engage and destroy a satellite in space with a little more power also can engage and destroy ballistic missiles in the boost phase.
John Pike.
I think one of my very real concerns is that in the absence of some kind of political deal with the Soviets that would encourage some restraint on their part in this field, that they are going to put up this space laser. That's going to be the world's biggest flashlight militarily, but is going to shock this country in a way that it hasn't been shocked since Sputnik.
Perhaps mindful of Sputnik, America's military planners are developing a major new defense program, the Strategic Defense Initiative. Over the next 5 years, an estimated $20 to $25 billion are to be spent in research alone on what has been called Star Wars technology. Lasers, particle beams, rocket boosters, new spacecraft, and more. Its director, Air Force General James Abramson.
Right now, this president and the president before him and all the presidents before them have no option. If there is one ballistic missile that comes in, his choice is to let it destroy an American city, let it wipe out a military capability, and just do nothing, and by doing nothing, encourage an additional strike, or to start a counterstrike, perhaps to start the end of the world.
A man who believes he's at least in part responsible for Reagan's Star Wars thinking is former Defense Intelligence Director Daniel Graham.
Well, it is my contention, and it is the contention of most of the intelligence community, that if the United States just sits back and does nothing, within 10 years, the Soviets will seize military control of cislunar space, that is, the space between here and the moon. And if they do that, then it really won't make much difference how many divisions or ships or planes we have down on Earth, because that is, in fact, the high ground of military capability now, space.
Graham's proposal is built around changing America's 20-year nuclear strategy of mutual assured destruction, or MAD. The MAD doctrine is based on the assumption that if both superpowers have the capability to annihilate the other, neither will act. Graham proposes building a 3-tiered defense space system. The first 2 layers are made up of orbiting armed satellites. They would seek out enemy missiles in their launching and coasting sequences. The 3rd tier would be a ground-based buckshot-like arrangement protecting American missile silos. This scenario disturbs retired Colonel Robert Bowman. As an Air Force officer in the 70s, he was responsible for the development of space weapons. Today, he is one of their most outspoken critics.
If you take a look at what they actually propose, each of the proposals has several layers, the last of which is always a point defense against our missile silos. The first layers, space-based layers, are so leaky, so many missiles would get through, that we always have to have that point defense around the missile silos. So it becomes obvious that what they're talking about when they say assured survival is assured survival of silos, not people. And what is the point of protecting missile silos? It's so they can exercise MAD.
Others criticize space defense because it ignores nuclear delivery modes other than spaceborne warheads, from a terrorist act to submarines to cruise missiles.
Fine. Because nobody is going to try to first strike the United States with that kind of system. So you got to remember what you want the defense for. You want that defense to drive the possibility of nuclear war as far towards zero as you possibly can.
But critics and advocates of Star Wars do agree on one point. Gigantic technical obstacles remain, a sober realization when considering the consequences of a less than perfect defense. Former U.S. Air Force Director of Space, John Story.
The problem with developing a system against ballistic missiles is right now we don't have the technology, the capability to build a foolproof system. Let's say that we had a system that was 90% capable of stopping every warhead the Soviets launched at us, and the Soviets launched 10,000 warheads at us, and we stopped 9,000 of them. That means we'd have 1,000 nuclear warheads impacting on the United States, and that's just not acceptable.
Space technology has helped forge a world where we are all in some way held hostage. Can this same technology offer hope for the future, or is the idea of space defense science fiction fantasy? Croft Erica, who died in 1984, held a special perspective on weapons in space. As a young German engineer in World War II, he helped build the world's first space weapon, a guided missile called the V-2.
I remember the time after World War II, where there was no doubt in anybody's mind that the ultimate weapon is the nuclear bomb. There can't be anything beyond this. Now we are talking about something to forestall the nuclear bomb. New weapons, laser weapons, in space, in Earth orbit. Now, anybody who believes that we stay with these weapons in Earth orbit is naive. Of course, there will be weapons in higher orbits that will attack those in Earth orbit, near Earth orbit. And then very quickly we'll be on the moon, because that's a very nice base from which to supply these things. It's a nice battleship. But what we have to consider is that the only end to this enormous weapons race is in the heads of people, not in a technological advance.
Another perspective on weapons in space from someone who has been there. Former Apollo astronaut Rusty Schreikert.
Are we mature enough to understand that we've got to go beyond that this planet is the home of all life and that we are all one life? There's no longer room for us versus them. It's all we. That is the critical question of our time. We are going to make that decision.
There's another battlefront developing in space, and this one has nothing to do with weapons. It's space for high finance and profit. No longer is space the province of just the two superpowers. Japan, India, and China are now aggressively entering the space transportation business. China is even hinting of its first manned launch. In Europe, 13 countries have joined together to create a common market of space, the European Space Agency. ESA's expendable Ariane launch vehicle looms as a formidable competitor to America's space program. One of these payloads could be Hermes, a miniaturized European version of the space shuttle. The overriding U.S. concern, even before the Challenger accident, is that America may be losing its competitive edge. Once NASA thought it could pay its way by launching commercial satellites, but the Reagan administration has ordered a reluctant NASA to get out of the satellite launching business. Turning away from that mission may be one of the most far-reaching legacies of the Challenger accident. This space version of supply and demand has caught the attention of individual entrepreneurs. Deke Slayton was one of the original 7 Mercury astronauts. Now he's heading up a new space effort.
Yeah, we're trying to put together a little commercial space program.
We have the vehicle that is pioneering the future of American private enterprise in space.
And we're now trying to put together an orbital system. Our objective is to put small payloads around 500 pounds into a low Earth orbit. And so we're designing a booster system to do that. We're designing payloads to go with it, and sensors and ground stations, and negotiating for launch sites and all of the things necessary to put a program together, and we hope better, more efficiently and cheaper.
Slayton's commercial group has added an unusual service to its list of potential payloads, a burial in space. For a fee, Slayton's company will scatter your ashes amidst the Van Allen radiation belt to circle the Earth a minimum of 63 million years. Most space competitors are concentrating on unmanned space opportunities. NASA, struggling to get its shuttle program flying again, continues to place emphasis on its manned program. The next major goal, a permanent space station. The station will serve as an observation post for looking down at the Earth and out into the universe. It can function as a repair shop and launching site for satellites and interplanetary probes. Some 30 shuttle missions would be required to assemble the space station. If NASA's vision is correct, the space station will become a doorway to the universe. It is a vision of the future which is also shared by the Soviet Union with its new orbiting space station Mir.
The Mir space station really is quite a dramatic improvement in the versatility that the Soviets will have in conducting scientific research in space. The major difference with Mir is that it has 6 docking ports instead of 2. And what this means is that they can have a crew on board, and their spaceship would occupy one of the ports, and they have 5 more to which they can bring up cargo craft or specially designed scientific modules. They can do all of these things with a great deal of versatility now that they have Mir.
The kinds of activity they're doing now, such as the space station and some other booster development they're doing, and some interplanetary unmanned probes, while they have their own immediate justifications and they're worth doing for their own reasons, they are the building blocks. They are laying the foundation for, at some point toward the end of the century, being able to say, well, now we know enough. Now we have the hardware and we're confident in it that we could send cosmonauts out to Mars.
But other futurists are looking back to the moon. If the Apollo astronauts were prospectors, then the next visitors will return as miners and they will excavate the moon for its resources. Here are the materials to build our solar-powered stations, starships, and space colonies of the future. Futurist Jerry O'Neill.
A space colony will be a large rotating sphere, about a mile in circumference, slowly rotating to make Earth normal gravity for the people living on the inside. Space colonies can be located anywhere in the solar system, and you calculate out how much material there is, how much energy there is to drive them. There's room there for expansion for the human race for thousands of years.
Yet in the near future, it will probably be machines, not humans, that will explore our solar system. The first interplanetary probe was launched a quarter of a century ago. Since then, we have seen the first glimpses of our planetary neighbors. These extraordinary pictures are from the surface of Mars, taken by the Viking 2 lander. The Voyager project remains NASA's brightest star, with its successful close encounters with Jupiter, Saturn, and Uranus. Still ahead for Voyager 2 is what promises to be a spectacular flyby of Neptune in August 1989. Pioneer 10, launched more than a decade ago, has now left our solar system on an infinite journey through the stars. Even more dramatic discoveries are expected by NASA's Space Telescope. When launched into orbit free from Earth's atmosphere, the Space Telescope is expected to see close to the edge of the universe, some 14 billion light years away. Peering so far into the distance is like looking back in time. The Space Telescope may see the birth of galaxies billions of years ago. In doing so, we may answer questions about the nature and fate of the universe itself. But in the wake of the Challenger accident, unmanned exploration of space has suffered. Schedules have been disrupted, missions cut back. Gentry Lee, head of Project Galileo.
Planetary science is in real trouble. After a decade of no major launches, we had planned to launch Galileo and Ulysses in '86 and Magellan in '87. That would have given us a look at Jupiter and its moons, look at Venus from a radar mapping point of view of the whole planet. And now these will not occur. Just when these missions will be launched is not certain, because we must wait until the shuttle is ready to fly again. Essentially, we have to wait in line until the Defense Department and other major missions are done, and then the shuttle is flying on a routine basis. This means it'll have been 12 or 14 years since we had any major planetary missions. Now, while all this is going on, across the ocean in the Soviet Union is a very deliberate, slow, but well-paced program to investigate Mars now. They did Venus first, now they're going on to Mars.
2 years from now, we hope to launch unmanned mission toward Mars. Then we would get an orbiting station around Mars, automatic station, and it would be the first recovery of man-made object in the vicinity of Mars after extremely successful Viking project. And we would try to do a kind of post-Viking type of science around Mars.
We began the process, and now as the Europeans, the Russians, and the Japanese begin exploring the planets, it looks as if there may well be a case could be made that we will perhaps become the Portugal of the 21st century. The Portuguese began the exploration of the New World, the oceans, Africa, and the Near East. But when the time came to colonize and actually benefit from those explorations, it was the British and the Dutch who led the way. I think that unless we have a rededication of national will, unless it becomes important again that we be preeminent in the exploration of space, the United States may very well become the Portugal of the 21st century.
We are just now venturing into the backyard of our solar system, but when will we travel to the stars?
When we talk about going to other star systems, we're talking very far ahead, probably anything from 100 to 200 years from now, I would say. Eventually, it's surely going to happen, and the people who go off to other stars are certainly going to be people who have been raised in space colonies in our solar system. The science for how we would do it is very clear-cut. The only energy storage mechanism that's strong enough to do the job is matter-antimatter. The one thing about the old Star Trek series that was scientifically accurate. The engineering certainly isn't here, but over 100 years, a lot of engineering can be done. There certainly will not be any human space flight to other star systems until the speeds of the spaceships can be brought up fairly close to the speed of light. I'd say 60 to 70% of the speed of light, so that the duration of the voyages can be cut down to a few years. A very good reason for that, because there's no point in going until the speed gets that high. Because if you embark on some very slow starship that's going to take many generations to go from here to there, the progress of technology back home is going to catch up, and people are going to be racing past you in more advanced designs.
When we will begin the journey to the stars, the voyage to neighboring planets, or venture back into space is unclear. Yet we are all space travelers. Throughout the ages, we and our ancestors have glided the universe aboard spaceship Earth. But it is our privilege to live when life is first emerging from the womb of our planet. If we survive the inherent risks of our technology, sometime in the next century, that very same technology will allow us to become a spacefaring civilization, to set sail on a new ocean full of cosmic wonder.